All right, so let's continue on finish on our OOP. So let's look at one more example of a class, right, which has some class methods, right? So notice, so here in this example, maybe let's make it a little bigger, right? So we have a CLS, right? We have reference, so we can make a so it is like calling house, right? So we could have a reference, so we could make a method, class method, which use this class reference to actually generate new house object, basically. Kind of interesting approach. I don't know if you want this, but this, of course, again, it's possible, right? So this one here, in this particular case, we are not really using it, right? We're not really, this method does not really use any class data, right? So we could add something here, right? And so class variables, so here we have the shared number of houses. And so this again is something, if you want to share something with your instance, will share same number of houses, right? So you can increment this. So again, idea being it does not live outside somewhere, it's part of the house like a reference basically. You know, I don't want to just discard cancel, right? So this will be interesting to see. Will things change here, right? We have our string method, which we know, we have paint. So let's see our house. So I have, of course, I can calculate square feet, which of course is fine, right? So just like, but let's make some instances, right? So my house is going to be a blue house, yes. And do you have another house? I have your house, right, green. So we have two houses. So let's see how many houses do I have, right? How many houses do I have? Will it work? It is works. So it works. So no. So we refer. I have, right, number of houses, right? So but again, so this is a little bit tricky, right? So it works because here. So we notice we change here. So what will happen? Let's add also this. Let's add something self number of houses plus 10, right? Or I don't know, plus 100, plus 10 something, right? Yeah. So this should be unique to each instance. So let's do random or something. Let's do random. Some number of houses. I don't know. I'll do randomness. We'll add some randomness, right? Import random. Random, right? And I will add some randomness here, right? So just some wild houses is random. Random, randint, I don't know, 100 to, I don't know, 200, right? Something like this, right? So just for show, right? Obviously, just for show. So let's take a look, right? So this should be realistic. Should be, of course, some fake data, right? Just for show. Obviously, it does not. So let's try this again. Will this work? First of all, can we do it? Yeah, our class methods work because before our objects. This works. So how about now? Let's take this one. It's still 2, so that's good. So class variable has the correct data, right? So, or how about our instance variables? Print my house, right? And so this should be random. Should be, right? This depends on language, right? Should be unique. Yeah, it is unique, right? Obviously, so this is the thing. So notice here. So we have access to class has some data, right? So class has some data. So this is for the class, but also, right? So this is shared. This is individual, right? So show that this is individual. Yeah. So obviously, okay. So what else we want to show, right? And now we get to inheritance, right? We have inheritance, right? Inheritance. So the derivation process of creating a new house. Sorry, not house. New class. A new class from a parent class is called inheritance, right? So a single inheritance is new class is subclass of a single parent class, right? So some languages, well, I think Python also, you can inherit from multiple classes. You will see that Kotlin does not let you do that actually, and there's some good reasons why it's actually usually not a good idea to inherit from multiple classes, right? Because one thing is, if you're inheriting from multiple classes, maybe there's methods, right? There could be a mess of methods. Maybe they have similar methods. You inherit from, like, I don't know, from a dog and a cat, and they all have, I don't know, make sound method, and and which one are you using, right? So kind of tricky, right? So, and personally, I don't like this idea of inheriting from multiple classes, right? So, and in general, I'm not a big fan of inheritance in general, actually, I'll tell you this. It's very rare that you actually need it. I much prefer something called composition. And that's also, I'm not alone in this, that composition is usually much more much more useful. So the class examples, like, inheriting here, you have an animal, right? It speaks, it doesn't know what to say, right? It has some data, and then of course dog, right? So this is where it gets tricky. We have this super, right? So what does super do? Right? We are calling, or yes, or parent constructor. Yeah. By the way, technically in Python it's not a constructor. Technically, it's init actually, right? It's right after construction actually, but initialization, right? So super. So very common again in OOP languages, right? So. And again, it gets kind of tricky, right? You have to keep track of what is the parent class does, right? And then you are overwriting it, right? So, again, of course, Python is very loose. It does not force you to overwrite, right? It doesn't have this contract thing, right? So we have dog and animal, cat, right? Meow. We get some flowing, right? Flow, right? So, and of course, buffalo, right? Stampede, right? So we can of course add some other things to that. So it still has buffalo, right? Still has speaking part, and what else does it have? It has, that's it, right? Eating something, right? So let's take a look at this. We have cat, animal, and dog, all inherit from animal. Cat, dog, and buffalo, right? They all inherit from animal, right? But of course they could have possibly some specific methods to them, right? But they all initially they all inherit from the parent class, right? So these examples I think are it's like everywhere, right? These animals, and then you have this class-based, biology-based instances. The hierarchy is kind of natural, right? But it's not so often that you have this kind of nice hierarchy, right? So unknown animal, 0 years old. So buffalo, beef. Right, and speak and stampede, right? So let's make them cats and dogs, right? Rex, right? On Kitty says flow, right? So Darcy. I don't have a Rex, but yeah. So the idea is that inheritance, it increases the possibility, right? It can create some dependencies, right? In this inheritance hierarchy, right? So you want to keep these abstract data types, but with inheritance you don't get that. I think in practice, composition is much more useful, and I think more widely used, right? So composition is what? We supply classes, objects from other classes inside. We save the data using other classes, basically inside our class, basically, right? So we combine multiple smaller classes to create larger, more complex objects. Yeah, from bigger class, right? So the class contains it does not inherit, right? It just contains the data, right? Instead of containing primitive data like integers on lists and strings, right? It contains actually other class-based objects from other classes, right? So this classical example, right? We have a car, right? And for now, this is going to be extremely simple car, right? We have what? Only engine and transmission, right? So components. So engine, right? Instead of, because you could somehow make a car that inherits from engine and transmission, right? But I think that's kind of does not really work very well. It's kind of squeezing. It's not a good approach. Okay. So instead we have engine. and we have transmission, right, and it also has some wheels, right. So what does the car have, right? So we're going to have engine, right. So we are saying that our car will going to consist of an engine, transmission, and wheel list, right. Theoretically, this wheel list should be defined in a stronger language. Would say this would be a list of wheels, right? Or list, yeah, list of wheels. I think like out like this, right? Is this how you write? I think this is how you write. I think, yeah. Or no? Or they did it correctly. Or this has to be capitalized like this. I forget now. I always forget this. Pylons, or is it just list? How do you write this? List, and then, come on, what kind of list is going to be? Just a list, I guess. But if we want to actually have it, of course, in a strongly typed language, we will have this, right, list. Well, it's not actually a list, it's tuple, right? We're passing tuple of what? Tuple of wheel, right? That should work. And let me see, why is it wrong? No, it looks okay to me, but maybe my again, of course, remember Python is not strongly typed, right? So wheel list or wheel tuple, right? And why doesn't class wheel? It looks okay to me. We are basically saying, well, yeah, I guess it says it doesn't like because I'm giving empty, right? There are no wheels, right? I'm not giving any wheels, right? So I guess I could leave it tuple, right? But even better would be in a more strongly typed language, I would specify that my tuple contains only wheel objects, right? But here I can't really force it, right? So let me see. I think I have a tuple. I think I don't need. Oh yeah, I think it looks okay. What doesn't? Okay, maybe I did too much. Oh, I guess I can't say default and then tuple. I think it's just kind of given. Yeah, I think you can't. Yeah. Okay, now it should work. Yeah. So my car. It has the requirement, you give it an engine, you give transmission, you give a wheel list, right? And of course we have something, and we can spin, right? Right here, let's make it car. So, what do we gain by this? We gain this multiple dot notation. Notice the composition, the multiple dot notation. Yeah, right? So my car, so by gaining this, I can do this, my car, right? I have dot, oh, I see, oh, engine, okay. So this, what we gain something called discoverability, right? You don't have to go look up a documentation, right? You can start doing your thing already, your work. You say, engine, okay, oh, it has horsepower. And you see, on any half-sane ADE, and again, Python is not a great example of this, right? It's already too loose, right? In strongly typed in Java, Kotlin, C++, right, and C#, you will have really nice annotations of this, right? So you have this access to pretty much everything, right? You have this, some bigger object, car, or maybe a car park, or maybe, I don't know, a parking lot or whatever, right? And you can go down to engine, and go to really finite detail, right? And using this dot notation, right? And you can change, right? So, and you can change even, again, not every language, sometimes it's not, in OP we are supposed to use setters, but yeah, you don't have to, right? So we change horsepower from 300 to 400 horsepower, right? And Tesla 1000, right? I hope it doesn't have 1000 horsepower actually, right? I think you have to convert the kilowatts to, right? And we have transmission, right? Gears, only one gear, right, for transmission, right? So, but the transmission, so again, we can add something else like engine, turn on, right? Let's make a method start an engine, right? Define self room, right? But of course, what you want to do is, of course, self running is false, right? What we do is, of course, self-running true, right? And stop, of course, stopping engine, of course, self-running false, right? So now our engine blueprint can be used, right? We can create an object from this engine blueprint for, of course, sticking it in a car, right? So this approach, I think, is much better, right? And again, I'm not alone. There is a big discussion about this. So composability versus inheritance, right? There are flame wars about this, right? You have much, right? DigitalOcean, right? And Wikipedia. So there's some good, right? So yeah, because otherwise you end up with something like this, right? Yeah, yeah. Oh yeah, duck, right? Yeah. So let's take now. Let's try it one more time. So I added the turn on engine. Let's turn on engine of the Tesla, right? So so Tesla engine start, right? Right. We can check running, right? Vroom, engine is running. Is Tesla engine running? Right. True, right? And of course, obviously, stop, and of course, so again with this, so of course you can keep going with these dots. If you include composed engine, can be composed of cylinders or whatever, right? Of course, depends on the kind of engine, right? Transmissions, and so on and so on. Of course, so pretty cool. I think this is a pretty cool idea, right? So of course we list, right? We can supply a real car, right? 7-speed transmission. I need, of course, define the list, right? And now I can pass a car, right? My real car spins first wheel, right? Spin all wheels, right? I'm spinning first wheel, second and third wheel, right? So, are we pretty clear on the difference in composability and inheritance? More or less, right? You guys are clear, right? Who work with OOP. Those who don't work with OOP are sort of like, what's the difference, right? Or so. Right? So we compose, right? We put other classes objects inside our objects, basically, right? And as inheritance, we sort of inherit, right? And it's not, again, let me show you some bad examples. So, so this is pretty wild, right? You have this duck, right? Duck test drive, yeah, red hat duck, mallard duck. So you can combine them, right? Things. So there is a composability here, right? And there's also inheritance as well in this example. That's a pretty wild example, right? So eventually, of course, you end up, bless you, a big ball of mud. What's a big ball of mud? That's what all programs tend to that. Eventually, it's just a big mess, right? Yeah. Like you said, your colleague, right, who works on that program, is it a big ball of mud? That web app. Who's working on you had a web app, Java, right? So is it a big ball of mud by now? Can you, like, do you have a clear picture of what everything does?
Mostly, but not fully.
Okay, so it's yeah, again, it's just a tendency, right? You know, we all tend to entropy, right? So that's of course true of programs. So it's good.
I am working on a project where at the start I had little experience.
Yeah.
Now I'm more experienced, but there is so much shitty code
Yeah.
that I have to fix.
Yeah.
So it is
You have a big ball of mud, right?
at some point it's just easier to rewrite your code.
Yeah.
When you learn something new.
But yeah, but there's of course famous saying that rewriting is very dangerous. Like in a big project, rewrite usually ends in disaster because yes, you should. It's easier, right? But there's so many examples when projects, you know, like a big successful project, they see, okay, yeah, there's all this messy code, you know, bad code, you know, S code, right? A big ball of mud, spaghetti code, and so on and so on and so on. You want to do a rewrite, but if you don't keep the old one, right, it ends up the new project kind of like maybe becomes too ambitious. A big example like Netscape Navigator, like one of the early program or early web browsers, right? They did a rewrite, I think, and it just sort of like. But by that time, Internet Explorer took over. So eventually, of course, they realized their problems, and eventually, of course, we got Firefox, right? But that is too late. Well, it's still around, but I mean, Firefox luckily is still around, but it's like 8 years later, basically. But that's not the only example. There are plenty of examples where rewriting is very, it's like, it's there's no like no true answer basically, right? It's like, yeah, if you're learning, you should, right? You should rewrite if you're learning, right? But if you actually under monetary concerns, right, rewriting is kind of, do I have a time to rewrite everything, or like do I just plug in things? Like sometimes, of course, with experience, sometimes you can do things that can replace the worst parts of the code, sort of like refactor, basically, right? But okay. So polymorphism, of course, is this kind of this big idea, right? That you have the same interface to represent different types of objects, right? So you have shape, right? You have circle or rectangle as an argument, right? So, so here's an example, right? So we add, of course, for example, addition, right? Simple example, add, right? We can add 3 objects, right? We can add 1, 2. We can add RTU, right? So in this case, since it's built in, the plus is overloaded, right? We can use it pretty much anything, right? So we just add an add method, right? And we gain this nice polymorphism. Again, I'm not going to show you C++ examples because you took that before. One more last thing today is reflection, right? Any C# users, right? Any C# users? No? Okay, right. So, but in general, so idea is that you can reflect on yourself, right? Self-knowledge, not only for yourself, but also for your programs. And so its idea is that you can access, the program accesses itself. It's not so, it's pretty normal thing actually, right? Because you have you have access to, program has access to computer, right? Unless you have special safeguards, you can access metadata about yourself, like what are you using, right? And of course, what you can do is theoretically, right? You can modify the running code, like in Clojure, actually it's easier, right? But you can change the data. So it's not something you want to do in a normal program often, right? It can be used for debugging, right? For debugging what's happening. You want to use, you can examine private fields, right? With debugging things, trying to find the errors, or breaking things, right? Hacking things, right? Then this is really nice, a nice idea. So we can access, so here's an example. So API, Java has a reflection API. Most OP language have some sort of reflection, right? So basically, you can see what you get access what to do, right? IDEs use that all the time, right? So if I have my dog, right? If I do a directory, right? I'm reflecting on the dog class, and I get, what do I get? I get a list of what's possible, right? I have all the byte and speak, which are the ones I define myself, and a whole bunch of stuff which is pre-built. But even I'm surprised actually that there is a some of these things are predefined, like less than, right? I don't think I don't remember let, right? It's already predefined already. For example, you can see also my methods, right? So you can save this, right? Right? So you can see all the methods for the dog, right? So first 3 methods, right? First 3 methods for dog class. Yeah, class, delete, right, and last 3 methods. So, so this is a weird example. So we can get sequence type. So we want to reverse a sequence, right? So here's the reflection idea. So you are building this universal reverser, right? Obviously, skipping the part where you are already, right? So we pretend that reverse does not exist, right? Yeah. Yeah. Right? We pretend this function, right? But we will ignore it. Yeah. So idea is this. So reverse. So we need to check, because reversing a string might be different from like a list. Of course, again, you can say, actually, in fact, Python lets you do it. So you start with empty sequence, right, of the type. So notice here. So this is a cool. So part here, right? So sequence type, right? So we utilize the fact that, right, in Python, right? So that not in all languages. So we know the sequence type is going to be what? Bool. It could be, so sequence type could be things like sequence type could be list, tuple, string, etc. Right? Etc. Right. So then, if it's empty, then we of course reverse, right? Silly example, first sequence 0, 1, right? And of course, so this is of course we are cheating here, right? So we are cheating here by using slicing, of course, right? So first sequence 1, 0, and final result is 1 to 0. And actually, are we actually going to, you know, reversed, right? We cheated basically because we reversed already using this, right? But idea, you can understand the idea. So let me see, minus 1. Let me see here. Let's say minus 1, right? Maybe something like this, right? And then we get the first one. Maybe something like this. Let's see. No. Yeah, so we can cheat basically, right? Let me see if this works. Right. Then, so reverse, right? R, right? So notice also again string, we get R instead of 10. So I think I messed up here. So we want to start from minus, no, we want to, well, I guess we'll do this, right? So let's just cheat. Yeah, well. No. Yeah. Oh wait, what did I do wrong? Oh, did I do? Right. I'm doing, of course. Sorry. Control Z, Control Z, Control Z, Control Z. Yes. This is actually using. Oh, yeah. Oh yeah. Right. So. Yeah, so it works, but so it reversed. So we use recursion on recursion, but of course not that would not be also might not be efficient, right? But yeah, but idea but this was not to illustrate the recursion. Idea was to do this type. So yeah, you can inspect yourself basically, right? So you can modify this type, right? You can also modify modules, of course, import. You can inspect your modules, for example, in Python. You have something called import library, right? So you can inspect what you have, right? You can get attributes, right, and see actually my function, right, add. You can call a function by, let me see, do I have it actually, this function here? And do I have it? Where do I have it? By my module, yeah, I have an extremely simple module, add and subtract, yeah, so I can use this. So basically, this is again not something you want to do in normal situation. You can import a module dynamically. Okay, so let's see if this works, right? So you provide, so idea is this, that you provide the name of the function and the module, right? So this is a big idea. So the big idea is that your module and function name could come from anywhere. Yeah, right? So so we don't have, so we do not have to have a fixed module name nor function name, right? So kind of interesting, but practically not sure how much where you would use it. So again, let's do a quick recap. So OOP, object-oriented programming, right? We use objects. We have classes as our design or blueprints on object instances of classes, right? So class we define by what kind of data we store them inside, also on what kind of operations we perform on that data. So polymorphism is the ability to use the same interface to represent different types of objects. Okay, so that's a short overview of OOP. Now we have a few more minutes. Let me give you a little thing of what we want to do on Thursday you won't be here, but maybe you have some spare time. So before next Monday, your task will be to install Kotlin somehow on your local computer. It's not required absolutely. When you have two ways, right? I would personally do. You can use Android Studio, of course. You can use IntelliJ, right? So how many of you use IntelliJ here?
Well, I've used it.
Yeah.
I use it, but just for work.
Okay. Yeah.
Sometimes to use.
So yeah. So of course, JetBrains is the owner of developer of IntelliJ, also is the inventor of Kotlin. So sort of they go pretty well together, basically, by that, So that's one approach. But also what I want to see also, maybe I'll try installing on code spaces locally on a command line. You can install SDK, and it should be runnable too. Also, maybe even a bit more like a low-level approach, but maybe even easier, right? Maybe it shouldn't be too bad, right? If you're running, on an Ubuntu-based system, so code spaces or any other Ubuntu system, right? That might be an approach. Yeah. Okay. All right. So guys, so Thursday you study for other things, all right? And I'll see you on Monday. Now some of you I'll see you in about 10 minutes, right? Yeah.